Bismillahirrahmanirrahim. Hello everyone, I am Dr. Mohsen from KFUIT Rahim Yar Khan. Today we are going to discuss analyzing remotely sensed data as a proximal sensing. Remotely sensed data. Sensing via electromagnetic radiation offers challenging opportunities. Temporal variation, crop versus soil. For crop properties, respective time of sensing is very important. Many ways of analyzing digital imagery than just looking at them as photographs. Make use of different bands of information captured by a sensor. Use these bands to create ratios and indices. In precision agriculture or GIS remote sensing application, most common band used are red and near infrared because they are specifically and sensitively related to the plant physiology. Basics of sensing for crops. In healthy, actively growing plants, blue light 0.4 to 0.5 micrometer and red light 0.6 to 0.7 micrometer are strongly absorbed by chlorophyll pigments. Near-infrared light 0.7 to 1.3 micrometer is strongly reflected in healthy, actively growing plants. Green light 0.5 to 0.6 micrometer is predominantly reflected by all plants. Here is the visible near-infrared and short-wave infrared reflectance, transmittance, and absorbance. And reflectance is in percentage, transmittance is also presented in percentage at different wavelength. How we do use remote sensing? Most important difference for vegetation result from biomass and chlorophyll. Estimating leaf area index. In this diagram, chlorophyll mass per unit leaf area constant at 50 micrograms per centimeter square. Wavelength versus the reflectance, and the wavelength for the reflectance of the leaf area index constant at 2.5 meter per meter square of the soil is presented. For detail, you can go on the RUSEC 1997 publication. Significance of red and infrared reflection in a field. General effect of vegetation on reflectance is more pronounced than difference that result from varying the soil or plant properties. Can only supply for a very rough survey between soil and plants. Sensing crop properties. To get more detail about crop properties requires an analysis of canopy reflectance curve relying on a full spectrum approach or basic of discrete wave bands. Basics of sensing. Weight at 1.6 meter pixel. True color based versus NDVI is presented here. The variation of the crop map is clearly presented in both figures. Reflectance indices is easiest method to get information about vegetation is to create a simple ratio near infrared to red reflectance. Ratio process creates a single band image. Vegetation indices, the most widely used and widely accepted, is the normalized difference vegetation index. It is the ratio of the uh, near infrared minus visible over near infrared plus visible band. So NDV, common value of NDV are between 0 and 0.8, less than equal to 0.1 sand, snow or barren area of rock, 0.2 to 0.3 grass and shrub, 0.5 to 0.9 lush crops or forest. As in the previous lecture, we discussed the indices are not the fixed value but depends upon the crop growth, crop phenology, crop health and all other things. These are the basic datum or the basic standard value that differentiate between the different type of land use. So here are the different type of index band used and their purpose is presented here. So you can go through it as we discussed the NDVI. So these are the different indices used for the different purpose. Soil brightness versus NDVI is presented here, and the leaf area index is also presented in the form of NDVI. Soil versus SAVI, soil adjustment vegetation indices presented here. NDVI versus SAVI is presented with respect to leaf area index. Red Edge NDVI. Steep increase in reflectance in the 690 to 730 nanometer region is known as the red edge. Normal difference red edge index is equal to presented here in the equation. Perpendicular vegetation index (PVI) assumption that there is only one soil type. Number of proposed indices to adjust for this Beard's law. Soil adjusted vegetation indexes infrared minus red over near infrared plus red plus L into N plus L. So how do we use indices? Simple ratio and commercial application. Useful for weed control in dry land or fallow farming. Allow for substantial saving in herbicide. Reduce environmental impact. Other than this, for water management and civil engineering purpose, to mapping the water resources management component, mapping groundwater or the water balance component, land use, land changes, land cover changes, etc. Weed seeker, weed seeker is here. NDVI in commercial application, green seeker and crop circle, measure of plant vigor. We need a lot, we need a little, we don't need much greenery. Other indices, hardware, OPT and RX crop specs, and these are the different hardware. Each may use different band for visible and infrared and index used. Thank you very much. If you have any question, you can ask me by commenting on this video on my channel, or a student can ask me questions and the detailed discussion on the Google Meet lecture. Thank you very much.